I'm Alex from Italy. I work at Edgee as a developer advocate. My goal for this session is to share with you a little bit of what we're doing, how we're using Stripe, how we implemented a consumption-based pricing model, which is not super typical for a startup. How many of you work in a startup? Well, nice. How many of you are technical founders? I'm curious. Okay, super, cool. So I've been a first-time employee in a startup twice. So not a founder, but still having a lot of fun. Before Edgee, I was at cloudacademy.com. That's the startup I joined about 10 years ago. Then I spent 6 years at AWS, and today I'm at Edgee. I'm going to share a bit of context because it's hard to understand the pricing model if you don't understand the product and all the challenges involved as well. So I really wanted to start from why does Edgee exist in the first place? What kind of problem are we trying to solve, and why is it important? Another question for you: how many of you work with data on a daily basis to make decisions, for example? Well, everybody just nope. Well, if you are, if you make decision based on data, it's really important that you can trust it, right? I mean, hard to disagree with that. The problem that appeared in the last 10 years is that a lot of things changed without everyone noticing. Privacy became a lot more important. We got cookie banners. I don't know if you remember, there were no cookie banners before, 4 or 5 years ago. New regulations came up, performance and mobile usage worldwide almost doubled or tripled in the last 10 years. So a lot of things changed day by day, and that had an impact on the data that we collect and how we can use it to make decisions. Well, I mentioned quickly a couple of potential issues. Here are the main ones. Ad blockers quadrupled in the last 10 years globally, and in Europe and the US and North America, it's even between 30 and 50%. So that's half of the data is gone. If you have a website and you're collecting how people use that website, almost half of the data is gone. Cookie banner acceptance rate, 31% on average globally. So that's 2/3 of the data lost just because people decline. Who always accepts cookie banners by default? Nobody. I mean, a couple people timidly, but most people have learned to just muscle memory decline. Traffic from mobile is more than 50% globally. So people on unstable connections, on the go, on the metro, on the tube. And that's a lot of data that doesn't make it to all the analytics providers that you're using. A lot of technical framework, especially on client side, JavaScript frameworks have dropped support for legacy browsers in the last 4, 5, 10 years. And that's another good percentage of data you're losing. So what we see with some customers is that sometimes up to 70% of the data you think you are collecting, you're not collecting. So the decision that you make based on you think the 100% of data is actually between 30 and 50%. Now, if you don't care, that's good. But it's hard to ignore this problem once you are aware of it. Maybe you're doing A/B testing, maybe you are looking at product consumption to instruct your roadmap, maybe you are, making decision about the future of your company. And if the data is wrong, well, the decision might be wrong as well. That's an issue, right? So this is the context of why Edgee exists. So in our experience, the single biggest cause of this is that most website analytics relies on client-side SDKs or client-side JavaScript computation, right? So whether you integrate things like Google Analytics or Segment or Amplitude, or whether you are talking to social media APIs like Meta Conversion API or LinkedIn Meta Conversion APIs, or maybe you're talking to cloud services like S3 or Kinesis or whatever. If that happens on the client, you don't have control of what happens on the client. And so, the data is just lost. Those third-party scripts are easy to block, even without considering, the performance, security, and privacy implications of, having those scripts in your as a dependency. Now, you probably heard of server-side tagging. If you work with analytics every day, this concept is probably not new. And the idea here is that instead of tracking directly on the browser, you take care of those integration on another server somewhere that only does talk to the analytics providers. Now, this solves kind of half of the problem. It's still easy to block, and it's not transparent, it's not open source. So what would really, really help here is to have some kind of CDN or proxy-like magic in front of your website that takes care of talking to the analytics providers, basically treating all analytics as a first-party API on the main domain of your website, right? So it's your website is www.example.com. All the analytics calls should go to the same domain. If you go somewhere else, the ad blocker, most of the time, you're just gonna block it. So here is the power of a technology that is called edge computing. Maybe you've heard of it in other, for other use cases like IoT or smart cities, smart factories. Here I talk about edge computing in the context of web development, and that usually means compute power running on top of content delivery networks. These networks have hundreds of points of presence or edge nodes globally, and you can run compute power on top of those nodes. That's how we are building Edgee. Here we go. Well, that's exactly what we do. So we pretty much act as a reverse proxy in front of our customer websites. We build this platform that allows customers to collect 100% of their data, because we take care of talking to the Google or Segment or Amplitude or Meta or LinkedIn even before the page is delivered to the browser. So the browser SDK is not in anymore. We take care of that analytics at the edge. There are a lot of components today, a lot of different categories, and we are going to expand into additional categories and types. Analytics is the first step for us. We are going into A/B testing, feature flagging, security, AI inference, and a lot more things. Now, that is the context to understand how we operate and why, and understand the business model. I would like to say it's not a typical SaaS, because typical SaaS in my mind, correct me if I'm wrong, is like subscription, monthly subscription, same cost every month. So we do that with a kind of a flat rate. That's how you call it on Stripe. But we also have a consumption component, which is the most part, pay as you go, similar to most cloud providers. So we have two dimensions: the number of requests that go through the proxy and the number of events that we are delivering to the final analytics destination. Plus some details like we have a free tier for developers, we have a free trial for running a POC for a month, because it's really useful to be able to collect data for a month and compare what you used to have, what you have today, and you can see if there is value for you. Plus some customization like private privacy, discounts, and all these things, of course, are natively supported by Stripe. We have technically three fronts on which we need to integrate Stripe. One is the API, where we do all the one-time setup for our multi-tenant application. This is running on AWS, as you can imagine, on EKS. We are using Go. This is like one-time setup, like setting up the customer, creating the subscription, blah, blah, blah. Then we have another very important component. We'll go deeper later into the meter events. If you want to do consumption-based, it means you have to sum up the numbers at the end of the month and charge your customers based on what they consumed. Okay, you need to be very accurate and so on. This is the important one, but let me also tell you about the front end. We started super simple here. We really loved the idea that we could evolve our Stripe integration over time. And we understood immediately that API and metering would be a big investment. So we tried to keep the front end simple. We went with a managed billing portal. It's super simple to integrate. It's a button in your front end, and then your customers have everything they need to manage billing data, update the credit card, view the invoice history, and all that stuff. For us, it's one button, and Stripe takes care of that. We do a couple of API calls from the front end, but that's super simple. We're planning to go a bit deeper here, of course, because it's a good starting point. But we want to integrate some Stripe elements, customization, for example. Now, let's get into the actual consumption-based model on Stripe. This is actually called not volume-based, as you would probably guess, but graduated pricing. This is a bit different, a small difference there. Volume-based is when you have multiple tiers of consumption, but once, you know, for example, from 0 to 10 something, it's this unit price. From 10 to 20, it's another unit price. And at the end of the month, you decide the price based on the consumption. Our model is a bit more complex. It's graduated, meaning that at the end of the month, you need to sum up all the tiers up to the final consumption. So if you consume the 100, you consume the first tier, sum up, consume the second tier, sum up, and then reach the final tier. So it's a bit more complicated, but Stripe takes care of all the math for us. So it's pretty good. In the code, it's a couple of lines of code of difference here. You just say graduated instead of volume, and you specify all the tiers. This is an example in Python, but you can have as many tiers as you want. One of the challenges that we had here is that we don't do from 1 to 5 or 1 to 100. We manage billions of API requests and data collection events per month. So the numbers are a bit bigger, and we need to send all those requests to Stripe. And as we'll see later, it's a bit of a challenge at this scale. What actually needs to happen is you have a couple of different phases at setup. You gotta create and meter a product and the prices, and this can be a good default, and then you can customize that on a customer by customer basis. That's pretty flexible. For each tenant, of course, you have to create a customer and a subscription that happens via API easily. The complexity of our integration is at runtime, where we have billions of API calls and events that happens every month, and we need to track those for each tenant, for each website they own, and so on. So these are called meter events. And an interesting side effect of using this system is that you can ask Stripe to generate a preview invoice for the current billing period, because it's kind of hard to give your customer visibility of their current consumption for the current month. So Stripe also provides a preview invoice API that you can call to get an idea of how much you're spending so far this month, for example. That's pretty useful for us. We could do the math, but they're already doing it. So that's pretty useful. This is how we defined, it's a bit small, apologies, but this is how we define the tiers in millions. So the numbers are a bit more manageable. So we have from 0 to 5 or from 5 to 50 and so on, with a price per unit of million. That's how you tell Stripe, hey, from this to that, the cost per million request is $2, whatever. But we also have the flat rate. So when you start paying in an enterprise plan, you pay this much per month plus the consumption. Okay, that creates a bit of a complexity to explain, but it's all good, and Stripe handles that pretty well. There is one thing we want to improve though, because by default, Stripe bills you the flat rate immediately, and then you pay the consumption and next month flat rate at the end of the month. So that could be slightly confusing. We want to find a way to improve that. Maybe I'll talk to James and Ben later. I'm sure there is a way. Now, some of the technical challenges related to the business model and architecture. Of course, it's a multi-tenancy application. We are very distributed. I'll show you what I mean here. For us, performance is super critical because we run in front of the customer website. We cannot add even 5 or 10 milliseconds of latency. So everything needs to be super optimized for speed. We are a startup of 10 people, so we need maximum flexibility, but cannot compromise on accuracy and resiliency, of course. Now, let me dive into the big issue here that we faced, which is the distributed architecture. We run at the edge. We are called Edgee, you can guess it from the name. But the diagram that I showed you before was super high level. Let me add a bit of detail here. So what actually happens is that we run on top of Fastly. Who knows Fastly? Fastly is a CDN, content-driven network, and you can add distributed applications on top of their edge nodes. So what actually happens is user from Europe will go to an edge location in Europe or in the UK, for example. User from the US will go to Fastly POP in the US and so on. So this is how a content delivery network works, and we run on top of their nodes. There are over 80 of those, so our application is running on top of 80 plus edge locations. On the left, you see all the billions of people visiting the websites that our customers own, and on the right, you see all the different tenants or websites that our customer own. So we are in there, and we need to handle billion of requests and send the data to Google in the meantime. And let me give you a hint of what happens inside each edge location. So we work as a proxy. A proxy is just something that sits in front of the website, calls what's behind it, and gives you back the response. Okay, it doesn't do anything fancy. We are a specialized proxy that takes care of data collection. So when we receive a request, we do a bunch of controls. We need to do bot detection. We need to take care of some edge cases, some requests. We respond directly without going to the customer website because we want to take care of that directly. When we do the pass-through, we talk back to the origin. We do some compression, decompression. We handle the cookies. We do HTML optimization. We do a bunch of stuff before returning the response. And then sometimes we need to collect events and send events to Google. So this could happen. Can I do this? Right. No. It's switched off. Well, whatever. So this could happen on the left here, where from the browser, a request is coming. And so we do the data collection directly there. Or this could happen when the response comes back from the origin and we need to do a data collection directly, like a page view, for example, before sending the request back to the browser. Now, because of some technical limitations, not going super deep tonight, this does not happen directly on Fastly. This is happening on an AWS hosted API. And then, just to give you the full picture, some of the logging, native logging from Fastly is actually going to a Google BigQuery on Google Cloud. So as you can see, some of the things are happening on 80 plus edge locations. The API for data collection that talks to Google is hosted on AWS, and the raw logs of Fastly are on Google, so the data is all over the place. Some of it is by design, some of it is because of historical reasons. But what is the problem? The problem is we need to send Stripe two informations: the number of requests passing by the proxy and the number of data collection events that go down to the Lambda, to the AWS API. So in theory, we could just send all the raw information to Stripe, but we're talking billions of requests and tens of millions of events. That's a bit of a problem because we want to scale another 10x or another 100x in the next 6 to 12 months. So Stripe has some soft limits and hard limits about how you send data. How do you send data? There is this idea of event ingestion for the Stripe meter events, right? You can send the raw events one by one, or you can do some pre-aggregation yourself, hourly or daily. Soft limits here, by default, 1,000 calls per second. We are already there, so that wouldn't really work for us. We are today, 2 billion requests, 60 million events per month, and we're just getting started. So we really need to not hit that limit. We could go up to 10,000 events per second with the API version 2, which we haven't used yet. And you can contact sales for up to 100K, but why? So no, we went with pre-aggregation, as you can imagine. Just to make sure we can scale, if you do a 100x scale in the next 12 months, we want to make sure the system still works. We don't want to redo everything from scratch. Another interesting detail is the idempotency, and James talked about this earlier. It's a huge challenge if you do things at scale with billions of individual events that could be duplicated. We don't want that because that will impact the invoice for the customer, right? It's important. So if you do raw metering, you can pass these idempotency keys, super useful. We could do it, but we decided to go with pre-aggregated, and that's super handy because basically if I send you the sum of the events at the end of the hour or at the beginning of the hour, the timestamp is automatically considered unique. So Stripe takes care of the idempotency for us, just overriding the data. If I send it twice, it's going to override it, not summing it up and duplicating it. So the documentation could be improved. I have some feedback for the guys, but it's pretty resilient to avoid it duplicating data and so on. Pretty cool. This is how we do the metering. It's a Go API, so the code is a bit not super understandable, but it's super simple. Once you have set up the meters, you just say, hey, this customer did 1,000 requests in the last hour. Done. Stripe take care of everything else. Now, one other thing that is super important when you do something like this is how do you take care of the pre-aggregation? What we decided to do is to run this ourselves once every hour. We have all these like 2 or 3 terabytes of data on BigQuery, so we can do the aggregation for the 2 dimensions. But what happens if, like James was talking about, what happens if the network is down, the API is down, maybe our Lambda, scheduled Lambda is down for how many hours, who knows? So we wanted to add a little bit of resiliency in the overall system, because again, this is impacting the customer invoice at the end of the month. We need total resiliency and data consistency. So once we fetch the logs from BigQuery for the 2 dimensions, for example, what we do is storing the last timestamp that was actually processed for that customer in a Dynamo table. We also store the temporary aggregations on DynamoDB because fetching terabytes from BigQuery is not cheap and free and immediate. So we do some caching and some temporary aggregation. What actually happened here is that we were building something that looked exactly like this, just to show some dashboards, right, for the customer to see how much they've consumed so far. So we ended up kind of adding the Stripe integration on top of this existing system, but we added a lot of resiliency because now it was not just a number on a dashboard, it was invoicing and billing. If you're on AWS Geek like we are, this is the full architecture. The API up here is stuff we didn't really talk about, so maybe we can ignore it. But what you can see from the middle here, Fastly talking to Lambda fetching data from Google BigQuery and sending data back to Stripe. This is the entire system end to end. There are some missing queues that James like a lot, but we'll adding some more queues in the future. And so there are 2 super critical components here. One is the call back to Stripe on the bottom left. And the other one is the call to all the analytics providers here on the right. This is all powered by serverless. So what we are going to do in the future is also distribute this across 30 plus AWS regions for speed and for performance. So the great thing about this is the cost is not going to be 30 times larger because the total number of locations will be the same pretty much. And so we're working on those kind of optimizations in the future. What is next for Edgee? As I mentioned, we are going to add a few zeros to all these numbers. We'll look into what happens if we start hitting some of the limits. So for example, we learned that there is a way to do a bulk metering where you say, hey, Stripe, I've put all the metering data here on this S3 bucket, go and read it, instead of sending the data via API. That might simplify some things in the future. We want to go a bit deeper with the front-end customizations. There are some custom pricing that we want to automate, and also work on the multi-account and that little flat rate plus consumption user experience that we want to improve a little bit. Overall, pretty cool system, is resilient, it's cheap to run. I think our AWS bill is like $2 or $3. So for these numbers, it's pretty cool. And we are ready to scale. So thank you, Stripe.